So I think we're recording. Yeah, we're recording now. Good morning, everybody. I don't know if you've seen videos that I've posted. I'm going to be posting this similar to how I posted those. Again, that's kind of, didn't say that very well, but effectively, I will be putting this on YouTube, much like I have the homework questions that I posted last Friday. So hopefully those were useful to you if you checked them out. If not, you can always go back and check out the YouTube channel that I've created for our class. I will remove that link to the top of our Google Classroom, but that is also where this will be posted. So good morning, everybody. Happy new week, week number 2 of our remote learning. I'm sure you've heard that we are moving this back or continuing this remote learning all the way through April. So we're going to start off today's class by basically just kind of revisiting some things. Well, rather talking, we're going to actually start it off with 3 good things. I know it's kind of a flashback to the past. If you want to participate, you're more than welcome to. Kind of trying to bring up positivity like we would on a normal Monday. But then I'm also going to rediscuss the agenda and expectations, since now we've extended our timeline here in remote learning. And then we're going to start every Tuesday and Thursday. I'm going to try to get a few example problems in. So I'm going to actually try to teach you a little bit more effectively than I did last week, because last week was mostly just an intro to this process. So I don't know if you've heard, but we have ASB has set up a virtual Spirit Week. So we're going to kind of combine the 3 good things today. So here's our virtual Spirit Week. Yesterday was I Miss You Monday. Sorry about that. I Miss You Monday. Obviously, we missed that, but no pun intended. But if you want to make up, just reach out to a friend, tell them how much you miss them. But today is Tune Tuesday. So if you want to participate, share your favorite song at the moment. Anyone have a favorite song at the moment they want to share? And y'all can unmute yourselves if you want to. Again, this is not forced or mandatory, but just kind of trying to keep it light, trying to keep it fun here. Anyone been listening to anything good that they want to share? Nothing? Alrighty, cool. All right, we'll try 3 good things then. I'll be lenient on this one, obviously. I'm not going to make us sit there like we normally would on a Monday, but does anyone have anything good, anything exciting that they want to share that's been going on in their lives? Mostly probably centered around staying at home, but has anyone had any grand successes since we last met? All right, we're all keeping it pretty low key then. Right on, sounds good. So then on that note, we'll kind of revisit on Thursday, TV Thursday. If you have a favorite movie or TV show that you've been watching since your time off, we'll talk about it if you want to. I'm sure we've all been watching or streaming a lot of things. It's just kind of what's going on. Tomorrow is WAG Wednesday. I know I'm not going to be meeting with you tomorrow, but I'll put a picture up of me and my tomorrow. All right, then on that note, there's our virtual Spirit Week. Cool. So I want to kind of go over some expectations and agenda. As you notice, what I have up on the screen here currently is effectively something that we were seeing pretty regularly in class when we were meeting together in class, and that's our class agenda. This is what we're going to be doing today. We're going to be learning about calculating logarithms by changing the base. I know some of you in here have already done this homework, so right on. I'll go back and answer any and all homework questions you have on that if you want me to. But if you haven't completed lesson 17 homework, I'm going to go over kind of a short lesson today. And I will be doing so with this S223 to 225. Again, those are our book pages. I'm going to be trying to use in about 5 minutes here, a short period of time to discuss those 5 problems, 2, 4, 9, and 11, and 19, excuse me. The resources side is the Ed puzzle that's attached to it. That's our changing the base Ed puzzle, and the lesson 17 homework, which is on pages 223 to 228, 1, 3, 12, 14, blah, blah, blah. All right. Before we actually do that, I posted something last night that looks like this, and it's a lot of information. Effectively, what I've done is I restructured our remote learning agenda, kind of the breakdown of what was expected of us, the Google Doc that I posted last week, and I tried consolidating it into a new expanded remote learning agenda, because you notice that we have a lot more time now, right? Like we're going to be going all the way at least through the 5th. So I kind of made this and it's a lot of information, but I wanted this to kind of be a summary of what we're going to be doing here for the next month and a half. So you notice I started with today. I didn't include as many links in this, but today our lesson topic's going to be on lesson 17. There's our ed puzzle kind of reminding us. You can find all of that on Google Classroom, by the way. And sorry, my iPad's not really working well with that. And we're going to be going over those problems today as well. So I posted this online on the Google Classroom. This is kind of our new updated full agenda for the next month and a half. Please reference this kind of as a pacing guide, kind of what we'll be doing on Tuesdays, Thursdays, and Fridays. I've tried to put every Tuesday, Thursday, and Friday in the mix there. Okay, cool. All right, then let's jump into our material for today then, barring anyone have any questions before I jump into the new material. Sweet. Okay, so by the way, again, this is recording, so feel free to reference it back to it at any time. All right, also what we're gonna do today is we're gonna talk real quick about lesson 17. I'm gonna make these lessons really brief and really short, just because we're gonna try to cap off our lessons about 10 to 20 minutes max. But starting here on page 222, we learned the change of base formula, and effectively the change of base formula is as follows. When we have a base that's not ideal, aka anything other than 10 or e, a common log or a natural log, we could change it into a different base, hence the change of base formula, by doing the following. Making a logarithm of our argument, sorry, let me color coordinate that a bit better. Making a logarithm of our argument, aka x, in our numerator, and a logarithm of our base, aka b, in our denominator. And on the videos that I've created of this on the YouTube channel already, basically what I was saying was, effectively we treat this logarithm here almost how it looks, where the x is above the b, and we create a fraction out of it. Meaning we could create a whole new logarithm by putting the x on top because it's floating above the base, and the b on bottom. Now that's kind of a cryptic way of describing it just by looking at a formula. And again, this kind of right here highlighted in red is a division sign. But we're going to go over a few examples to help us see this on the next page. What you see as I zoom down here, or zoom out and scroll down, a little bit more accurately said, those are a bunch of properties that we've seen before. Anything to the 0 power is 1. This was our power product that we said. Here was our reciprocal property, highlighted in blue right now. That was our product property of logs. Quotient property in purple, and in green was this was our power product. The red ones were actually our same base property, excuse me. Brain's kind of all off right now. All right, that was kind of a quick summary. Now, what you see here on this next page, page 223, this is the start of our homework. I already did numbers 1 and 3 for you. Those have separate videos or a separate video on the YouTube channel. I want to spend our time today going over on this page numbers 2 and number 4 by utilizing the change of base formula. And again, the change of base formula is named as such because we are changing the bases. And what I mean by that is, on number 2, we have a logarithm that does not have an ideal base. By that I mean 7. Again, ideal bases are either base 10 or base e, and anything with a log base e we call it natural log or ln. So since 7 is neither 10 nor e, we can't really use a standard calculator to solve it, so we change that base real quick, and here's how we do so. We rewrite this as a quotient or a fraction of logarithms, where we put on top our log of our argument, which is 11. We highlight that in blue. We make a fraction of the argument, log 11, over the denominator, the log of our base. Let me color coordinate this as well, 7. Now, as I mentioned on the previous video, and I'll continue to kind of re-stress this today, what we're really doing here is we're turning an improper logarithm, a log with a base of 7, I don't like that, into a more common logarithm, a log with a base of 10, 10, 10, but we know log base 10s, you don't need those there, by using a quotient there, a fraction. And now the reason why we do this is because now we could use a calculator. Sorry, I forget where my scientific calculator is, right here. And on this calculator, all I'm going to do is I'm going to type in this division problem that you see me circling in blue right now. So we're going to do log of 11 over log 7 function, a logarithm of 11 divided by my logarithm of 7. Now what we see is the answer 1.23227, and that's our solution to this problem. Excuse me. So the answer rounded to 4 decimal places was 1.2323, because I believe it was 23227. And again, I got this number being circled right now in black through the calculation there on the calculator. Again, the change of base formula is effectively the ultimate cheat code. It allows you to use a calculator to solve any logarithm by simply changing its bases, by simply turning it into a division problem. And those division problems, you can see color coordinated, come from the argument in the numerator and the base in the denominator. All right, I'm gonna do number 4, rapid fire real quick. Okay, so this says log base 2 of the argument 3. I'm going to change this into a fraction. Log of my numerator is going to be that 3. Let's do a different color here. Log of my numerator is going to be 3, and that 3 comes from right there. And my denominator is going to be log of 2. And that 2 comes from the base. Again, kind of association, it kind of looks like the 3 is hovering on top of the 2 in a standard logarithm. So it's like the 3 is on top, aka in the numerator of the change of base formula. Now we can evaluate this log base 2 of 3 by using the change of base fraction that we have going on there. Kyle, I like the light show you got going on. And I'm just going to use a calculator here, log of 3 divided by log of 2. So again, real quick, using the change of base formula as an ultimate cheat code, log of 3, because now it's all calculator work, divided by log of 2. Means our answer is going to be about 1.58496. But I wanted this around this to the 4 decimal places, so like 1.5850, because that 6 rounds that 9 up to the next 10 place, 5850. There's our answer. All right, before I move forward, anyone have any questions specifically on the change of base? I think it's pretty straightforward and pretty user-friendly once we get the hang of it. If you have any questions, speak now. Right on, cool. All right, is anyone having any trouble hearing me or seeing the screen, seeing all this stuff that I'm mirroring from the iPad? We're all good on that? Right on, cool. Okay, let's do a couple more problems real fast. We could do the same thing here with natural logs as well. It's the same, it's literally the same logic. You could turn a log with a base of 8 into a log with a base of e, a natural log, by just doing the same exact thing. So I'm gonna kind of cruise through this quick. Argument 16 goes in the numerator on top. Base 8 goes in the denominator on bottom, and then we just execute this operation right here on a calculator. I'll do this one and then we'll cruise past it real fast. It was ln of 16. Oops. ln of 16 over, aka divided by, ln of 8. We get 1.3 repeating, so sorry, sometimes 1.3 repeating, so 1.333, or 8 to the 1.333. 3 is approximately our argument of 16. All right. Again, because I don't think we had any questions of the first one, this next page on page 224 is effectively the same thing, just now instead of log base 10, a common log, we're working with log base e or natural logs. But make sure that when you do this change of base formula, you still execute the division, aka use a calculator to get your final decimal answer. All right. Last problem I wanted to go over for today, and I'm kind of cruising through this lesson pretty quick because once we get the idea of changing the base, it's pretty much just rinse and repeat over and over again. But I wanted to go over number 19, the challenge problem. But before I do so, I'm going to actually post here real quick on the Google Classroom one of our RLQs, our remote learning questions, those Google Forms that I've been posting up, trying to post them up every few days. So that way, if you have a question, you could reach out to me and I can try to get back to you either via email or by recording a video. So please feel free to fill out that Google form if you have direct questions and you don't want to ask them now. And you want me to do a specific homework problem, I'll make an individual video for you on that. All right, so that's a last thing that we're going to talk about in terms of content, aka material for today, is this problem here on page 225, problem number 19. So we want to rewrite each expression in an equivalent form, excuse me, that it contains only one base 10 logarithm. So basically, when we're trying to write something in an equivalent form, that means we're trying to use those properties of logarithms. So I'm going to zoom in here on number 19. And the big thing that I notice right off the bat is I don't like that base. That's okay. We know how to change the base now. And another big thing I notice is the argument itself. That can be manipulated. And what I mean by that is I could turn 800 into an operation or a combination of operations of other numbers, maybe let's say like multiplication, that will make this base of 2 a little bit more redeemable. Okay, now effectively this is what it comes down to, is I know that I can, using the product property, rewrite a logarithm with a base of 2 and an argument of 800 as follows. 8 times 100, okay? So we can rewrite it as such, and that's our product property, which basically states that I can break 800 into factors. Okay, so we can work with that from there. Now what I can do is I can rewrite this logarithm here as log with a base of 2 and an argument of 8. And here's what the product property allows us to do, separate it into an addition problem plus log with a base of 2 and an argument of 100. Okay, so all I've done there is I highlighted here in pink is I took the original argument, broke it into factors, and then executed the product property to make it an addition of those factors. Right on. So now we're cruising. We're manipulating it, trying to write it with our properties in an equivalent that contains only one base 10 log. Well, it just so happens that I know what log base 2 of 8 is, because that's really saying 2 to what power equals 8. 2 to some power equals 8, and 2 to what power equals 8? Well, 3. So this whole thing of log base 2 of 8 simplifies down to 3. And log base 2 of 100, I don't know personally 2 to what power, it's called y, equals 100. I don't know how to do that because 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th, hopefully I'm right quickly off the top of my head, is 128. That's not 100. So what I can do now is leverage my change of base formula, and it pretty much asks us to get down to 1 log base 10 formula, and that's how what I'm going to work with here. And say, all right, the log with a base of 10, don't need it because it's common, of my argument over the log with a base of 10, or regular log of my base. So now what we've done again is we have turned it in through the product property into one thing that's definitely solvable, log base 2 of 8, aka 2 to the 3rd is 8, 3. And we've changed our second portion of this product property of logarithms into a solvable problem, log of 100 divided by log of 2. Now I'm going to simplify this down. Log, again, change of base is the ultimate cheat code. It took something that I didn't know and made it able for me to use a calculator. Log of 100 divided by log of 2. About 6.6439. About 6 sorry, as I cruise back to my calculator. I'm getting this from the bottom right-hand side of my calculator right now, 64389. 385, which turned into 39. Then we can add those up and get about 9.6439, and that would be effectively the answer to this problem. But what I do want to say, or really what that's saying, is 2 to the just over 9 power would give us 800. But main thing I want us to get from this is that the change of base formula, which I'm about to circle in red, takes any single logarithm and allows us to effectively solve for it, which basically means through the change of base formula, we can solve for any exponent anytime. If we have an input, if we think back to our PERT formula, a ending amount equals principal times e to the RT. And let's say we didn't know one of our inputs in our exponent, like the time it would take for an investment to mature, we can now solve for it with logarithms by using our change of base, maybe specifically our natural logarithm in this case. So change of base formula unlocks any exponent at any single time by using a calculator. All right, that's a lot of information. So hopefully you were kind of following along with that. Again, number 19 was a challenge problem, but feel free to go back and review this or hit me up with any questions that you may have through either the RLQ, which is on the Google Classroom, either right now or via email. I'd be happy to answer any and all of those. All right then, so like 5 minutes left, 5 minutes left of class. I do appreciate you all being here. Much love for that. Hopefully you're all doing well. If you have any questions, feel free to ask now. If you want to just reach out and say hello, you can do that as well. If not, we're pretty much wrapping it up here today. That is our lesson for today. And tomorrow, sorry, Thursday, excuse me, we're going to be talking about how to solve logarithm equations, basically by using all the skills that we have talked about thus far in this unit. So, anyone have any questions, comments, or concerns? We all good? Right on. If you have anything, please unmute yourself or open up the chat box. Let me know. You can type it in. If not, have a great day, everyone. I do appreciate your time. I miss you all, and I hope you're being safe and healthy. See ya.
Bye.